speaker tonight is Ms. Mosmi Roy, and her talk is on deep learning based digital pathology image analysis towards 3D volume reconstruction. Ms. Mosmi is a research scholar at Stony Brook University, New York, working in pathology imaging domain. Her expertise includes computer vision, data analysis, and machine learning modeling. Mosmi is enthusiastic about the research on AI and big data analytics, in particular machine learning based approach for digital pathology imaging, an interdisciplinary field connecting computer science and biomedical research and healthcare. Mosmi demonstrates exceptional research capabilities with published papers in top medical imaging conferences. Recently, she developed a deep learning based approach for histopathology object segmentation, which will help with much improved diagnosis of diseases through digital pathology. Mosmi enjoys traveling and cooking new dishes. So before I hand over the session, I request all the participants to mute their audios, and the participants can have the queries by raising their hands once the talk is completed. Now it's over to you, Mosmi. Thank you.
Thank you, ma'am, for the introduction. So, shall I start sharing my screen?
Yes, ma'am. You can.
Okay. Good evening, everyone. Myself, Moshumi. So, I am currently a graduate research assistant at research scholar at Stony Brook University, New York. So, today's talk is titled as Deep Learning Based Digital Pathology Image Analysis towards 3D Volume Reconstruction. So, in today's talk, first I will give a brief introduction about this PhD admission procedure in US universities. Then I will briefly describe about my research topic, and followed by a brief introduction about deep learning architectures, the recent trend of research. And then my particular research currently I'm working on, that's the whole slide image registration, and then how 2D to 3D volume reconstruction we can perform. And finally, I will conclude this talk. So I will start by giving a very brief introduction, like how you should proceed to apply for the PhD program in any US universities. Since there are a lot many university in many states, so you have to be very careful and you have to do a pre homework before choosing the universities. So first you have to choose 5 to 10 good universities. So you should not aim too high for very top universities because they mostly reject the applications. So but you should not go for very mediocre, so you have to do that wisely by visiting the website of the universities and who are the professors and what kind of research and how is the computer science program in those universities. So keeping all these things in mind, you can just choose select several few universities, 5 to 10, because you also have an application fees when you send the application. So and also beside that you have to prepare a few things. First is your transcript, all your academic records, and you should have a strong resume. So the resume should focus the academic research background, and it is better to have some publication during your master program. Alongside that, you need 3 reference letter from your previous professor or your company manager if you are working in some company. And so those reference letter, it holds a lot of value because those in those letter it should be focused about your research inclination, how you are interested in the research work. And you also need GRE and TOEFL score. For different university, the score cutoff is different, so you have to check that from the university web portal. So your TOEFL score should have to be above that cutoff. And lastly, you have to prepare a statement of purpose, which should be to the point because the reviewers don't have to read long essays. So you have to just show what kind of research activity you perform and what is your passion for research and what kind of things you have shown, like you have proved to be a researcher. So these kind of things you have to mention in that statement of purpose. So all these things you have to send, and finally they review your application. So once you get the admission, The first 1.5 year is mostly in most universities, the rules are mostly same in US. So first 1.5 year people spend for coursework. So the rules for PhD qualifier here is little different from Indian university. So you have five qualified courses you have to pass with A or A negative grade, along with some credit courses. So 1.5 year people spend on completing these courses. Along with they start exploring the research topics, and this is a good time to talk to professors to see which is your interest and what they are actually working on which topics. So because at the end of first year it is good to have your advisor, then you can immediately start your research. Typically, it takes 5.5 to 6 years. In some cases, it takes 7 years to complete this PhD program in US universities. So this is our university, Stony Brook University. This is a really very good campus. We have also railway station in our campus. So this is a really very big university. So now I will come to my research topic. So my research is mostly focused on analysis of digital pathology images using deep learning methods. So I will come to all these words like what is digital pathology and everything in following slides. So my previous work, like last 2 years, I worked on developing some segmentation framework, that is the deep learning based model, to perform some segmentation of microanatomical structure in whole slide liver histopathology images. And my work is kind of interdisciplinary of computer vision, machine learning, deep learning, and also medical imaging, and some kind of biomedical informatics as well. My current ongoing research is mostly focused on image registration and 3D volume reconstruction from 2D image slices. These are few publications I already have throughout like last 1 or 2 years of my PhD program. Okay, so now I will give a brief introduction about digital pathology. So human tissues are first chemically stained to highlight certain objects such as H&E staining. This H&E stands for hematoxylin and eosin. This staining is used to highlight certain objects like nuclei or cell, and then they are put into glass slides. These glass slides are scanned with digital scanner to generate high resolution whole slide images. So here you can see these are the glass slide and they are scanned through this digital scanner. These are very high priced machines. These are actually placed in this pathology section in hospitals. So, and they generate these high resolution whole slide images representing human tissues. Now, this is a typical whole slide image. It looks like so. This color is because of the staining, H&E staining, and most digital pathology images have this kind of color staining. Now, processing these whole slide images could extract all information, including microanatomic objects such as nuclei, vessels, and we can use such spatial derived data to understand the disease and supporting diagnosis. So here in this figure, you can see the cells are segmented and their boundaries are delineated by this red bordered region. And finally, we can estimate several features, cell features, which finally helps to do some higher order task like tissue grading or tumor grading and some prognostic task. So this is the typical whole slide image and the digital pathology, the data exploration, like how from the glass slides we can get the whole slide image in the software format. So now here are example of some more images, such images of H&E stain. Here you can see this is a breast cancer image. So this is a typical patch extracted from some region of interest of a whole slide image. You can see the cell nucleus and the cytoplasm regions. Similar, this is a liver tissue. So we can have different region of our body. So we can cut the section of the tissue and we can stain with the different staining colors, and we can then extract the images in the digitized format. So digital pathology is actually the process by which these histology slides are digitized to produce high resolution images. And this digital pathology is becoming very common. So this is a very new research field and it is becoming very popular nowadays because of this growing availability of these whole slide digital scanners, which helps to scan those physical glass slides in the imaging format. The digitized slides actually it affords to the possibility of applying this image analysis technique for this digital pathology for different kind of applications, like we can perform the detection, segmentation, classification of different microanatomic structures inside these tissue regions. Like you can see these white regions, these are actually fat cells. So once you start working in this field, you need few domain knowledge and domain expertise. So once you start working with this kind of images, you have to acquire like what are the cells nucleus and what are the diseased cell, like diseased tissue versus the normal tissue. So there are a lot of feature wise variation and lot of different variations you can observe. And for that's why we need the help of pathologist or domain expert to understand this kind of data. These are very different from normal scene images or normal data. So a number of image analysis tasks in digital pathology, they involve some sort of quantification. Now, what do we mean by quantification is like of cell counting or tissue grading, like some sort of classification. So to perform this kind of task, it requires some identification of some histologic primitives. These primitives are nothing but nuclei, mitosis, tubules, epithelium, etc. So as a result, we need to develop an efficient and robust algorithm to analyze this kind of digital pathology images. In this figure, you can see that so this is a segmentation, this is a detection, and this is a classification task I have shown. So for segmentation is nothing but delineating the accurately the boundaries of these objects, microstructural objects like nucleus, it can be epithelium, it can be tubule, and how accurately we can delineate these boundaries. So this is the initial task. Once we have extracted these regions or we need to detect this cell region, we can do the next stage of feature estimation. Like it can be the morphology features, we can estimate the density or area of this region of interest, and from those kind of features we can do some high order task like tissue grading or prognostic prediction or some more higher order task. So next I will, so here I am showing a typical whole slide image, histopathology image. So it is stained by H&E staining. That's why its color is this purple. And this is a very bird eye view, like the low resolution view of this whole image. This pyramidal structure actually shows like it can have different resolutions, like it can be low resolution to several high resolution, different layers. So that means different magnifications or resolution. When it is at high resolution, the size of this image can be several GBs. Like I have worked with examples where I have one single image size is 3 GB, around 3 GB, when it is at the highest resolution. That means we can enlarge, and look into more detailed inside of this tissue region. So we can see the cellular structure, like as you can see in this kind of example. So this is like more detailed view inside the whole slide image. So this is at some high resolution, like 20x magnification. Now, when we go to the top level, like the lower resolution bird eye view, then it is lower resolution. It is showing the whole image, but the internal details are missing here. So a region is an area of interest to be extracted, displayed, and processed. So here we have shown some region bounding box, and we can extract the tile by tile from this whole slide image. This tile size can be like 256 by 256 or 512 by 512, which are actually good to feed to some deep learning model. So you can extract patches of any size from these high resolution whole slide images. So a region can be represented by this 2D window. It can contain object of interest such as pseudopalisade, or it can be a nucleus of certain characteristics, and it can be many more different structures. The baseline image actually has the highest resolution, that is called the level 0, which has all the details inside the tissue region. You can visualize the internal detail structures. So that is called the multiple granularities of these whole slide images. Now I will give, so this is an overview of how the histology images look like, how the pathology images are, and what are the whole slide images. Now I will give a brief introduction about deep learning methods. So as we all know, deep learning is very trending now, and everyone using, this is a buzzword now in computer science, everyone using deep learning architectures for many different applications. It can be text processing, it can be audio, it can be images, or any field people are trying to use to automate their task to generate the output or prediction by these deep learning models. So it has an inbuilt automatic multi-stage feature learning process that learns the rich hierarchical representation, which are nothing but the features. So once we have such kind of images, which is nothing but a indoor scene image, so we can extract different level of hierarchical features. Like first we extract the low level features. This is followed by the mid level features. So you can see first it started detecting the edges. Then it is extracting the mid level features. And this is followed by the high level features. And after several stages of this convolution, like this kind of feature extraction, finally, the trainable classifier classify it whether it is an indoor or outdoor scene based on all these extracted features it has learned through several stages of iteration of backpropagation. So, so here I have shown a typical convolutional neural network, which is very popular for image analysis. So for imaging, we need mostly the convolutional neural network based architecture. This is a classification model where you can see there are several filters, convolutional layer with different filter sizes, followed by max pooling. And finally, we have converted it to fully connected layers, and those fully connected layers are fine, that is a dense layer, finally helps to classify in 5 different class levels. So this is a typical architecture of a convolutional neural network. Now, as we know, there are standard CNN models are available for different kind of task. Like classification, we have ResNet, DenseNet, which is very popular recently. And similarly for segmentation, we have UNet, FCN, SegNet, and many more existing deep learning models. Now, as a researcher, it's our goal to develop, come up something new from these existing architectures, and we depending on our application or our task. So now I will show how these deep learning things we can use for our specific data, like these whole slide images. Now, as you get the flavor of these whole slide images, this is very different from normal, image, like it can be the scene image, it can be cat, dog, or some other images, or the digit data, which is very popular for deep learning model building. People first use the digit data 0 to 9. So those are very simpler version, simpler data, but our pathology images, it itself is very complicated. Now we have to prepare this data to feed into the deep learning model. So that's why we need a lot of pre-processing before we use this data set for training a CNN model. So here you can see there is a train stage and another is the testing stage. So first, this is a typical whole slide image where you can see multiple tissue region. Now it is a bird eye view, like very low resolution view we have shown, but actually if you enlarge, you can go to more detailed structure. So when we extract the patches, we need at the highest resolution so that we can visualize the cell, the nucleus, and the cytoplasm level details. So once we extract the patches from these tissue samples, you can see, so the task here is to identify whether it's a tumorous tissue or non-tumorous. So we need some features which actually help the model to learn whether it has the tumor property, tumor characteristics or not. So when we extract the patches, you can see the normal patches, the nucleus, they are very different from the tumorous patches. So that's why, so this is the tumor region. As you can see from there, they have extracted these patches, and this is some normal tissue region. So that's why we need some region of interest, and we extract these patches, and then this is our data set, because these are like small images, 256 by 256 or typically 512 by 512. And then we feed these individual patch. Like, so since one whole slide image has several GB of size, we can extract lot of patches from one single whole slide image. So that actually helps to gain lot of training data. So in terms of training data, suppose if you have 15 to 20 this kind of whole slide image, or we have few handful of this whole slide image, from there we can acquire lot of training data to train our model. So once we acquire, so also we need some color normalization, because when we do the staining, people do the staining, there is a lot of color variations across the images. So that's why you also need to do the color normalization as a pre-processing stage. Once we have this training data, we feed it through this deep learning based model depending on our task. It can be a classification, it can be a detection like cell detection, or it can be the segmentation. Based on that, we have to use the deep learning architecture. We have to come up with our own architecture variations of that. And then finally, it can classify each patch as tumor versus non-tumor. So as you know, the deep learning training is very straightforward, similar like the standard one. We have to do the back propagation and optimize the parameters, the trainable weights. And finally, when we have the trained model, then comes the test stage. In the testing stage, we suppose we have a new whole slide image which the model hasn't seen before. So this is a new specimen. So when we have this whole slide image, first we will extract the overlapping patches. This time it is little critical because during testing stage, we need overlapping image patches. So once we feed these patches through the deep learning model, it will give some probabilistic value of this tumor versus non-tumor. These probabilities are mapped on this spatial location of each image patch, because we have this spatial information where exactly this patch is located in whole slide image. So once we have this spatial information, we just map this probabilistic value for each corresponding patch, and we can generate this heat map to show that, okay, this is the tumorous region and these are the tumor patches with this probability. This one near 1 means this is tumorous, and near 0 means this is non-tumorous. So this rest of the tissue region representing it is a non-tumorous property, but only this region it is showing that it is a tumorous. These are the tumorous patches. So that's why it is a very good visualization to show that how the tumor, so this is a tumor image, whole slide image, and where is exactly the tumor properties or features located, we can actually show probabilistically by this kind of heat map. So this is one example of how whole slide or histopathology images can be analyzed through deep learning model. Next is another case study, another example to give you a flavor like how we can use this whole slide image analysis through either machine learning or deep learning based architectures. So this is the study of like whether the patient has heart failure or not. So this is a typical whole slide image. So from there, we have to extract different ROIs, that the region of interest. First, the patients were divided into training and test data set. So when the whole slide images were scanned and region of interest are extracted for this image analysis. So cross validation is used to train and validation purpose. So it can feed through the machine learning model or it can feed through the deep learning model to finally predict whether this patient has failure or non-failure. So here the task is little different from the previous one. So here all ROIs, the region of interest from one patient should given the same level, because whether this patient is diagnosed like clinically or pathologically diagnosed with heart disease, depending on that, all ROIs coming from one single patient, this whole slide image should have the same label, failure or not failure. So here there is a catch that when we extracting this region of interest, it's not necessary that all regions contains same characteristic properties. So here we need the expert pathologist intervention to detect those region of interest which actually contains the characteristic information or characteristic features which actually help this model to learn and finally predict, like finally giving the prediction whether it is a failure or non-failure, the patient has heart failure or non-failure. So because of that, so once we normal people we start working, we need lot of interaction with the domain expert, the pathologist, and we have to learn which region contains this kind of characteristic features. So this is a critical task to find these ROIs. We cannot randomly select any region from this whole slide image and feed to the model. Then that model may not be the robust one, or it cannot be the efficient to finally do the prediction. So because many region contains actual characteristic features which helps the model to learn. So these are few examples of how this digital pathology, whole slide imaging, and the deep learning can be combined together to do a lot of different analysis. So this is the kind of classification task. So for segmentation, we also have the pipeline to do the segmentation, and sometimes there are a lot of post processing after this model prediction result. We have to combine back the patch-wise prediction to generate the whole slide image prediction, like the one I have shown here. So here you can see after this patch prediction, we have to generate again combine, like the tile wise, we have to combine all these tile spatially across their location, and then we have to generate the final prediction for this whole slide image. So the point is we have lot of pre-processing stages, and we also have, then we have the deep learning framework, then we have lot of post processing to generate the final prediction or final result for these whole slide images. Okay, so now I will come to the whole slide image registration. This is my current research area, research topic, and how we can do this 2D to 3D volume reconstruction part. So image registration, so this is a new topic. Like, so for registration there are a lot of different literature where people have addressed this registration issue for radiology images, but for pathology images, this registration, it is a really very new area of research. So you won't find many research paper or some very few handful of literature is available, but those are also based on classical framework like image processing, classical architecture, not anything based on deep learning based model. So image registration for using deep learning based model for pathology, this is a totally very new field of research. So so this pathology image volume, as you know, these are the glass slides I already shown in previous slides. So from there, through the digital scanner, we can generate these 3D whole slide image volumes. Now, 3D pathology imaging actually enables stacking the serial sections. So these glass slides, actually, these are some serial sections. So you can think it as a time series kind of thing. So these are serial section, and it enables stacking the serial section, which have significant potential to enhance the study of both normal and disease processes. So compared to 2D objects, it provides more accurate shape, structure, spatial relationship, and many more better information, which are actually missing in the 2D visualization of these serial structures. So we can generate 3D volumetric model from these 2D slices. So the first stage of this is volume reconstruction is performing the image registration. So when the glass slides are acquired, these images are not in the same coordinate, they are not aligned properly in same coordinate system. So this is a process of estimating the optimal transformation between two images, which helps to align all these slices according to their coordinate system, so that we can stack each one of them together on top of that, so that we can generate the volume structure. After the registration, the next stage is to perform this segmentation of different region of interest or different microstructure. Here we have shown the vessel segmentation. So once so for segmentation, we can use classical or machine learning or deep learning based method to perform this anatomical structure segmentation. Once we have this vessel segmented in each of these slides, then we can actually perform the reconstruction of cells or vessels. So this is a this is actually reconstruction part. This is wrong, this is not segmentation. So after segmentation, this is actually the volume reconstruction. So this is actually vessel, and these are cell region. These are synthetically shown, like how we can reconstruct back the 3D volume structure of cells and vessels in some 3D coordinate space. So this is an overview of how we, from the acquiring the glass slides, from the digital scanner, we can acquire these serial slides, and then we can do the registration followed by segmentation. And then finally we can stack this volume to generate or to segment and to reconstruct some microstructure or the each slides itself. So there are few challenges in the registration of histopathology images. So these are few stages of acquiring the, like how we can acquire the serial slides. So these are kind of donor block, like from the patient, the specimen from where we collect the specimen, like these tissue structures. Then actually it is done some sectioning or cutting of this tissue section, serial sections they cut, and then do fixation. So these are some physical stages performed in the pathological department. And then they perform the staining of these glass slides. This staining is nothing but so these actually, this also generates a lots of variation in the pathology images because of the staining stages. The staining can be different kind of, like I only mentioned about H&E staining. There are different other variations, IHC, immunohistochemistry staining. So these are different modalities, like these generate different modality of pathology images where different kind of structures are more better visible. Like for H&E staining, we can visualize the nucleus and cell and fat cells, the cytoplasm more better way than other structures. So once we have this staining, then we can generate these histopathological slides. These slides are like serial slides. Once we have these physical serial slides, then they do the digitization through those digital scanners. After this digitization, we can have those whole slide serial section images. Those serial images, then we perform the registration, like aligning across their coordinates, like all these sections. So once we align them, performing the registration, then we can do the volume rendering and we can generate the 3D histology reconstruction view of those from those 2D slices. But there are challenges of this kind of registration of histopathology image because of this complex geometrical deformation and these stain variations induced from these individual data preparation steps. So these are typical data preparation step where for extracting those slides and then generating the digital images. So here we have I have shown like histopathological image registration, how it looks like and how we can visualize pictorially, like what is actually the image registration. So suppose this is my source image and this is my target image. So you can see that source image, the sizes are different. And also now this is, suppose this is my region of interest, or this is the hallmark region. These are called like hallmark region. So you can see this orientation or alignment is very different from the target image. So what we have to do is transform the source image into the coordinate system of this target image. Because of that, we have registration methods. Now these all are classical methods, these are nothing related to deep learning. So till now for pathology images, whatever you find in literature, all are classical based method to perform. Those are like manually fixing the parameters and then they perform the registration. But these are not robust, or these are not the parameter setting is not universal for all image data. So that's why that's the drawback of using these kind of classical models, because these we have to manually fix the parameters and this is not, nothing is automated. So once we have this transformation function, that is the deformation field. So there are rigid registration and there is also called non-rigid or non-rigid registration. So the non-rigid registration, it actually deform this field and then try to align this target image, source image according to the target image. There are several results for these are existing classical methods to perform this. SARF is like extracting the features, scale invariant features, like that is shift and similar like SARF. So these actually help to extract the features across the feature point and then aligning by matching those feature point. So you can see many methods are not able to actually align. It is losing the information, cutting this section abruptly, and we are missing the tissue information, and which is our region of interest, we are losing that part also. So, and this example I have taken from this paper, reference paper. For more details, you can refer to this paper. They have proposed another classical model. Nothing is deep learning. So classical model to register this target image across the source image. So their parameter setting and their method able to work on this kind of images, and this is actually aligning this target across the, sorry, the source image across the target image. Now you can see their results. So still we have tissue region missing, but our region of interest, this is actually acquired properly, and this is aligned more according to the target image. So image registration you can also perform for histopathology image in different resolution or image several multi-level magnification. Since I have already shown you this multiple granularity of whole slide images, so we can extract, so this is a whole slide image, the total whole slide image. So you have the serial sections for this whole slide image, and you can perform the registration in this level, or you can extract some region of interest. And so this is some internal details, and you can extract for all these serial section the same region, and then you can align across this region, and you can similarly you can go to more detailed view of these internal structures. So that is called multiple granularity or multi-level registration. So you can do the registration at the whole slide level. You can also do the registration at some lower, like internal detail level. This is a cellular level. So here we can see the cell structures, or the cellular structure is more visible than this whole slide image view. So that is called multiple magnification. So we can select the sub-region interactively through the software, and we can feed this kind of serial data to perform the registration. We can do it by classical method. We can also use the deep learning based model. Okay, now I will give a brief introduction about how this medical imaging registration is performed through deep learning, and then I will go through the volume reconstruction part. So this is a typical pipeline for image registration. So as we know, this is a source image and this is a reference image, and we need some sort of, we have to provide some sort of transformation. This transformation, actually, this is a transformation parameters which helps to interpolate the source image to generate this I prime, the transformed source image. Then we match this I prime with the reference image to find how similar they are after giving this transformation. So once we calculate this similarity calculation, this has to be maximum. So that actually helps to do the back propagation and update this transformation to again give the deformation or transformation to the source image. So this is my back propagation in the deep learning field. So by this way, we can generate the final target image, like the final transformed source image, which is very similar to the reference image. So here you can see a typical deep learning based architecture, how it is used for this kind of registration. So here comes the CNN model. This is mostly similar like segmentation one, because we have to reconstruct back the actual moving image. Now based on that, it generates some deformation transformation parameters. That is actually the deformer or spatial transformer. This transformer is applied to the moving image to match it to the fixed image. Now this is the resampler. This resampler is nothing but that spatial transformer which applied to the moving image to match it to the fixed image, and by that way we can calculate the loss and do the back propagation, and finally generate the output transformed image or moving image which is very similar to the fixed image. Now this is an example. So you will find, so the catch is here that there are very handful of research paper where they address the microscopic image registration. This is only one paper where they have addressed, research paper where they address the histopathology image registration, and their method is also very simplified based on convolutional autoencoder based architecture. So most literature are addressing the radiology images like MRI, PET, CT, and other modalities, because those images are much simpler than our these histopathology images, which are more challenging, because of this high resolution of whole slide images. So what they have proposed, first they have reconstructing back the images. So they are reconstructing back the original image. So this is the encoded feature map. Once we have this encoded feature map for source and target image, then based on that, they perform the similarity matching of those feature map from the source and the target image. Here you can see some of the registration results. So this is my this is our so these are reference image and these are the moving image, and these are the results of the registration. So these moving images are registered according to the source image through a deep learning architecture, deep learning pipeline based on convolutional autoencoder. So some registration results you can see those are quite good, and some are not that very well aligned according to the source image. So this is the visualization of the image registration after registration. When you stack these serial slides, this is the kind of visualization of the registered results. Next, I will come to 3D volume reconstruction. So once we have these registered serial slides, this 3D volume reconstruction and examination of this tissue at microscopic resolution, this has significant potential to enhance the study of both normal and disease processes, mostly particularly which have the structural changes or those in which the spatial relationship is important.
Excuse me,
of the
Mosmi.
features. Yeah.
We are running behind the time. It's
Okay.
2 minutes. Another speaker is waiting. Sorry to interrupt.
Yeah, I'm just going to the last slides. Yeah.
Thank you.
Yeah, these are few applications for the like this volume reconstruction, why it is important. So here, here you can see some of the results of these volume reconstructions. So these are like 2D views, and from there you can just, after stacking the serial slides, this is the 3D, and after volume rendering you can see this 3D visualization. So as you can see, this only, I will go through this only C section, which is the liver tissue, where these are the disease region, and those are more better visualized in the 3D volume structure than the 2D slices, where a lot of informations are missing. So we can, so after registration, we can do the volume rendering to perform this kind of volume reconstruction and 3D visualization, which helps to make more better understanding the disease and also the prognostic learning of this kind of data images. So that's the overview of our research work. So if you have any question.
Thank you, Mosmi. So over to the participants. Participants having any queries can raise their hands in the chat box and post the queries.
Hello.
Hello. Yeah.
Yeah. Ma'am, I have a query about, is there any publicly available data set to perform operation on this kind of data set? If you know any publicly available data set in the public domain?
Yeah. So are you interested in what kind of task? Is it like classification detection or the registration specifically?
Is simply classification detection.
Yeah, there are a lot of pathology image data set public. So TCG, you can go to the TCGA portal. There are a lot of you can find a lot of pathology image data also.
Okay. Thank you.
TCGA, yeah, or it's TCIA. I suppose it's TCIA or TCGA. Just search by that.
TCIA. Okay.
Yeah.
Thank you.
There you find radiology as well as the pathology for different sections, brain and like all human section. You can find a lot of data, public data.
Okay. Thank you.
Yeah.
I think we will take one more question because we are short behind the time. Our next speaker is also waiting. So we will take one question. Dr. Amin Rao, can we make him unmute?
Thank you very much for giving a long explanation about your work. Really very happy to hear you, Mosmi.
Thank you.
And I would like to, general question is the data sets, where these data sets are generally available, those who are interested, maybe PCOS problem, other maybe chest or other things, brain data sets, where generally these are available.
So I mentioned one is TCIA. This is a very big portal where there are a lot of pathology image also available along with the radiology. So people are also nowadays do research on multimodal, like it's like radiology and pathology. You can mix these two modalities as well to do the analysis. So in TCIA portal, you can find a lot of pathology data as well.
Okay, thank you very much, Mosumi. Thank you very much.
And I can find some more publicly available data since I work with the hospital. So I have like more like specified data. So I can find some more resources and I can follow up with Tilottama ma'am to send her some link later on if you need really some data for research.
Yeah, really, we need a lot of data regarding this one.
I can help to acquire the data, like public data.
Yeah, I thank you and Anurag University for conducting this session. Thank you very
Thank
much.
you so much. Thank you.
Thank you.
Okay.
Sure. Thank you, Moshe. Yeah, it will be a great help and wonderful talk and insight you have given. I have one question. Like usually these PhD programs, you have MO like in collaboration with the hospital, correct? You don't
Yes.
go with these public data sets, correct?
No, mostly I work with the specified de-identified data.
Oh, okay. Thank you. All the best for your PhD.
Thank you, ma'am. Thank you. Yeah.
Now I request my co-chair Deepika to display the appreciation for Mosmi. Thank you.
Thank you.
Thank you, Mosmi, for giving an overview on the underlying biological mechanisms of pathological evolutions through image analytics, and also the deep learning multi-stage feature learning process. Your talk on the challenges of registration of histopathological images is going to really help us research aspirants who are working in the same domain. Thank you. Thank you, Mosmi.
Thank you.
Thank you, Ms. Mosmi. Yeah.
Thank you.
Yeah.
We'll be sharing the attendance sheet. Sorry.
Yeah, please share the attendance sheet, madam, for the session, this session.
Once the session is completed, we'll be sharing the sheets. Attendance.
Okay, not for this session. After this session, you will share?
For two sessions.
Both the session complete after both the session.
Okay. Yeah. I request all the participants to attend all the session, because based on the attendance only, the final certificate is going to be issued. So minimum 80% attendance is required. Everyone must participate. And if you have any questions, any queries, please reach to us directly. We have given our phone numbers. We have given our mail IDs. We are happy to help you. Okay, thank you. What about the next speaker? Who is the next?
Hi, it's me, Joy.
Mr. Joy Prakash Sai has joined. Welcome, Joy.
Yeah.
Thank
Good
you.
evening, sir. Yeah.
Shall I proceed?
Just a minute, sir. Just a minute.
Okay.
I think our team will just start the session. Yeah.
Yes, sure.
Hello, team.
Yeah, Deepika ma'am.
Sir, can you say the name of the participant? I mean, at what time you have logged in?
Madam, this is
Obule, sir? I'm unable to find your name, sir. That's why.
Mr. Joy Prakash Sai, JOY, it will be.
Yeah, Obule, sir, I'm trying to make co-host, madam.
Yeah, HOD
Okay.
CSC AU, ma'am.
Yeah?
HOD CSC AU.
Okay. Okay, sir, I have made.
Divya ma'am,
Yes, sir.
share that screen. Ma'am.
Yeah, sir. I'm just sharing, sir.
Yes, sir. Shall I start, ma'am?
Please, sir, start it. Yeah.
Very good evening to all. This is Dr. A. Oblesh, Assistant Professor in the Department of Computer Science and Engineering, Anurag University, Hyderabad. It's a very honor, very privilege to me to introduce Mr. Joy Prakash Sain. Mr. Joy Prakash Jain is presently pursuing his PhD in Computer Science and Engineering from Wright State University, Ohio, USA.
Hello, sir. Voice is not audible.
It is very low, sir.
Yes, am I audible now?
Audible. Yeah.
Yes, sir.
Those who are
Yes,
not
audible.
able to.
Sorry.
Yeah. It's
Sorry.
coming.
Yeah, Mr. Joy Prakash Sain is presently pursuing his PhD in Computer Science and Engineering from Wright State University, Ohio, USA. He received his MS in Computer Science and Engineering from WSU and BTech in Information Technology from West Bengal University of the Technology, West Bengal, India. He is currently working on information extraction from unstructured text using machine learning algorithms. During his master's, he has worked on several projects for analyzing patients' health based on their social media posts. His research has resulted in several co-authored publications in international conferences like WWW, SIGIR, and ICPR, and was recognized by the Computing Community Consortium as a blue sky vision idea. After his bachelor's studies, he has worked on several projects as software analyst in Hexagon Capability Center, India for 3.5 years. It's a great profile. Thank you, sir. Thank you for accepting our invitation. Now I request our speaker hand over the session. Thank you, sir. Now you can start, sir.
You should be able to see the screen, share content at the bottom of the screen. Yeah, great.
Yes, sir. Your slides is visible now. Okay.
Yeah,
Okay.
thank you, Joy. Yeah.
So thank you so much for the invitation and the brief introduction, and for organizing this event and inviting me to present on this platform. So I hope everyone is doing well and your family and friends are safe in this pandemic. So my name is Jayaprakash Sen, and I'm pursuing my PhD from Wright State University, and my research is on information extraction. So before this is the brief outline of today's talk. So before getting into the research, I'll just quickly go through a few points, and I would like to share my personal experience, how I got into research. Then I'll go through two of the projects that I was involved in during my master's. that is identifying depressive symptoms from tweets and assessing the severity of health state based on social media posts. Then I will give a brief introduction of named entity recognition, that is my current research. So I'll not go through the technical details. I'll just introduce the task because due to the time constraint. So if you have any questions, please feel free to interrupt me in the middle. So here are my few of my thoughts, like how I got into research. So for those who are interested presently in the bachelor's or master's and interested in higher studies and planning for studying abroad, so maybe some of you are aware of these are the prerequisites that you need before applying. Like you need to write a GRE, you need to have an English proficiency test, and these are the documents that you need to have while applying, like transcript from undergraduate or graduate. You need to have a resume, you need to write a statement of purpose, like why do you want to study in a university, what is your research goal, what is your accomplishments, and letter of recommendations from your advisors or other professors. These are the few optional documents that will boost the application if you have, like a research paper if you have been involved in during your bachelor's or master's, or if you have any certifications like from Coursera, Udacity, or if you participated in any hackathons or conferences or workshops and so on. So these optional prerequisites are basically boost your application. That will also help you once you get into a university. This will also help you into getting any assistantship or any other opportunities, or in future getting a job. So how I got into research. So for those yeah, who are in bachelor's or master's and you don't have any research idea or how you means how you can proceed. So these are the few steps that I followed and it helped me. Like first step, I would suggest connect with your university professor and showcase your interest. Like go through their research profile, what are they working on, and go through their research papers and just summarize it. And if it interests you, just connect with the professor and let them know that you are interested in research. So they might have lots of ideas, and you can slowly start working on it while you are in undergrad or even in masters. If you find some other professors who are in some other universities, and if their research interests you, you can email them and reach out to them and let them know that you are interested in their research, and you can share your ideas. In a way you can connect with them. Maybe you will have an opportunity to collaborate. Other ways would be like connecting with the masters and PhD students, like because those masters who are currently involved into research, or PhD students, they are doing research. So try to connect with them, and they might have several ideas, or you can also participate in their research and take a task, and in that's how we can proceed. So in a way, you will have initially, if you don't have any research ideas, you can slowly start working with them and you can build your profile. I would suggest attending conferences, workshops, and master's or PhD thesis defenses, because there you might not, if you don't have any research ideas, you'll get to know a lot more about in several ideas like people are working on. Like some people are working on vision, some people is working on security, some people are on other areas. So you'll get to know a lot more ideas and what are they working on, and these thesis defenses, you can try to attend those. So you'll find what are the research a PhD student has done and what are the tasks that need to be done. I mean, yet to be solved. So you'll get an idea. If you don't have any research idea, how you can proceed, like what to do. So these are the steps that I follow. So I'd suggest read at least one paper a day. You can start with reading a survey paper in your area. Let's assume you are interested in a computer vision or image analysis. So read a survey paper in that area. You'll get a summarizations of what's going on in that area. Once you get an overview, if the implementations of the proposed approaches or the existing works are available, you can, if it interests you, you can go through the code and make sure you understand once you understand, so in a way you can make some changes. Then you should try to implement on your own. Like for example, a some small algorithm, if the implementation is not available. So once you start implementing it, you will get to know each and every details. So in a way, it will give you an idea what are the things that you can change, and you can make your own. And you can start working once you go through this. Let's assume you have gone through several survey papers, or you got some existing ideas that out there. So you can start working on the existing idea if you don't have a new idea, and try to improve it. So slowly, you eventually you will get some new idea after reading lots of papers. So I would suggest initially to read at least one research paper a week. Another thing that helps me, and previously also it helped me, and now it still helps me, this is following the researchers on social media like Twitter and LinkedIn. So if you are interested in vision or natural language processing or other machine learning areas, so you'll find the researcher there in Twitter or LinkedIn. So follow them or connect with them. So you'll find they are sharing their research work before it is even published. They share their research paper in archive, and they share on Twitter, or they share interesting talks and all. So once you connect with one researcher, let's assume, you get all the details, whatever they share. Slowly the social network, they will suggest you connect with the similar researcher based on your interactions. So in a way, you will have a lot more exposure to the research area. So if you have any questions, please feel free to interrupt me. So now I will go to the next step. That is, this is one of the projects that I have worked on during my master. So this is identifying depressive symptoms from tweets. So what is a depression? So depression is a mental health disorder. So here are a few details. So it's affecting around 322 million people globally. This is from a World Health Organization report. And this depression is one of the leading cause of death, like suicide. It can, so depression, based on its severity, it can lead to suicide. So what can we do? So early detection, if you can detect it early, you can make sure that it doesn't get severe, and you can eventually prevent suicide or other mental health disorders that depression causes. But depression, usually depressive patients have a social stigma, like they tend to not to share with their friends or families personally, but on social media they are very active. Similar things happens when they are visiting a medical health practitioners, like a mental health experts. So usually how it is done, they approach the mental health practitioners once in a week, once in 2 weeks or a month, and they share their thoughts, what's happened. But eventually, due to the, so based on the studies, it has been found that due to social stigma, they tend to hide certain things, but they tend to express those things on social media. So here are a few details that I got from World Health Organization report, like how depression is affecting worldwide in different regions, like African region, Eastern region, European, and so on. So this total 322 million.
So Jenny,
You have any question? Okay. So how depression is assessed? So in clinical setting, patients go to a mental health expert. So they follow this assessment questionnaire that is called patient health questionnaire. It has 9 questions. So this is used to screen, diagnose, and measure the severity of depression. So PHQ-9 has 9 questionnaires, as I said. So it and that user that identifies user mental health status based on this 9 questionnaire, and how frequency it is occurring in past 2 weeks, let's assume. And based on the frequency, they try to assess the severity of that patient. So these are the 9 symptoms or the areas that patients is asked the questions about. So whether they are lacking interest in something or doing something, they are feeling down, if they are having sleeping disorder, let's say sleeping disorder, I mean, let's say they are sleeping too much or sleeping very less. They are feeling lack of energy whole day. Eating disorder, like they are eating too much or they are not eating at all. Low self-esteem, like they are feeling bad about themselves. Concentration problem, like if they are not able to concentrate in their work and not able to progress, and if it continues. Hyper or lower activity, if a patient is moving too fast or moving too slowly, like they are always cautious that other would notice. And self-harm is the most severe cases, like they tend to harm themselves, like that lead to suicide. So here are a few examples that I put from the tweets. So for each of these 9 symptoms classes, like for example, lack of interest, I don't think I care anything about at all, and so on. So this shows like the patient is lacking interest in doing something, or next is feeling down if the patient is saying I'm alone at home, no money and depressed, and so on. So these data sets that we collected, those are for those are from patients who's made their profile public on Twitter and who are going through clinical diagnosis. So, and after collecting the data, after several pre-processings and all, we annotated the data by 4 different annotators from different backgrounds and native speakers. And after that, we evaluated the annotations by a professional psychologist, and then we proceeded to the next step. So here are a few examples you can go through for different symptom categories. So after doing the analysis, we found these are the frequent patterns that the patients usually use for each of the symptom categories. Like for lack of interest, they use this bored, disgusting, sick of, or tired of it. For feeling down, depressed, alone, isolate. For sleeping disorder, they use awake, sleepless, nightmares, insomnia, and so on. So using topic modeling algorithms, we extracted these frequent patterns. So used unigram, bigram, and trigram to extract these patterns. So while studying this, going through the data, we found a few challenges. So these are not all, but a few challenges that we identified. Like people tend to use figurative language because there is a limit. The Twitter, it provides a limited number of characters. So user has to, or the patient, whoever is tweeting, they have to shorten their text and they have to express their feelings or whatever they're going through. So they often tend to use figurative language. Like this is from one of the user who has gone through clinical diagnosis. So this is a tweet. My skin is a paper and razor is the pen. So figurative language, for example, sarcasm and metaphor. So here skin, here paper and pen, all these words, these are used in metaphorical sense. So this indicates a tendency to self-harm. The skin is a paper and razor is the pen. So they tend to self-harm themselves using a razor, like cutting their skin or hand. Other challenges are implicit sense. So implicit, so like if you go through the sentence, it doesn't explicitly say what the user or patient is going through. For example, what if life comes after death? Grab my knife and find out myself. So this indicates a self-harm tendency. And other challenges are polysemious words and context. So context is very important. So in which context a patient is using the words. So for example, just we have seen in previous slides the frequent pattern. So just you matching those frequent patterns or words won't solve the problem because the context is important. For example, bleeding. First sentence, woke up and nose started bleeding. So this is not related to any depressive symptoms. although the word most bleeding comes under these frequent patterns. But in the second sentence, I wish I had the nerve to press the blade deeper into my skin so I don't stop bleeding this time. So in this example, it shows the self-harm tendency. So bleeding is used in both the sentences, but the meaning of the sentence is different. So one is non-depressive and one is depressive. So in our work, we have tried to solve partially these first two areas like figurative language and implicit sense. We didn't encounter this polysemious word and context. So I'm not going through the details of how we created the data set. You can go through the research paper. It is still under review. Once it is available, I'll share it. So how we created the data sets and evaluated with professional psychologists. We'll make the data set available if you're interested. So we collect so now once we have those annotations, we train a machine learning model. So what are the steps? These are the overview of the steps. I'm not going into the technical details. So we given a user and his tweets. We first, this is a primary steps of pre-processing for any natural language processing task. Then we have a machine learning models for natural language processing, and it has the capability to solve this figurative language like sarcasm and metaphoric sense and to tackle the implicit sense. And it will eventually classify the tweets into PHQ-9 symptoms, like the 9 symptoms categories that I've shown. So based on the frequency, again, as per the PHQ-9 symptoms, like clinicians as they follow, so you can evaluate the severity of a patient based on their social profiles. So PHQ-9 usually evaluated based on 2 weeks data of a patient. So it's following the similar pattern, we try to emulate the PHQ-9 scale on social media. And we have the tweets we have collected for every users, like potential depressive users. We have chunked into 2 weeks tweets and we have evaluated. You have any question? Okay, I'll move to the next one. This is another research that I was involved in, assessing the severity of health states based on social media posts. So here are the few statistics that will motivate why did we go through this research, why did we perform this research. So around 80% from a Pew Research, around 80% of internet users in US, they explore these health related topics on online health communities like health forums like Patient Info and Daily Strength and so on. Out of these 80% internet users, 63% look for information about specific medical problems and 47% look for medical treatment, or they ask for suggestions, what kind of medications they can follow, or if they're having any problem, they ask for suggestions. So why this is important? Now, when a user or a patient posts on these health forums, they expect a response from other users who have gone through the similar conditions or who has experienced similar problems. So on these health forums, health professionals or human moderators, they voluntarily go through the post and answer those questions and help them from a distant supervision. So if we can go through this health forum data and if we can sort themselves or arrange themselves based on their severity, it will attract or it will help the health professionals or medical professionals or the human moderators who are involved in voluntarily responding to other patients. It will help them to assess the severity and it will help them to prioritize their response. Like a patient, if it is the patient is very critical condition and asking for help, if we have a tool that can analyze those his post and assess the severity, and if it is highly severe, then it can present to the human moderators and he can prioritize, okay, which one to answer. In a way, it will help them, it will help the patients to get immediate response. This kind of study also will help for pharmacovigilance studies for pharmaceutical industries, like if patients or users are expressing any side effects of any drugs, or if they are mentioning in social medias, so they can use those data and extract the drug information and side effects information, and you can control what kind of steps to take to monitor it for drug safety. So these are the class labels that we created. So for medical conditions, these are the 4 class labels, like recover, exist, and deteriorate, and other. So recover means if the patient is expressing like he or she has had some problems and now it is recovered, so now they are doing well. So a human moderator or a health professional, he doesn't need to go through all his long posts and just to know that the patient is recovered. Instead of that, they can focus on the other severe categories, like if a person is having some health issues and over the time if it is deteriorating, then the human moderators can focus on those posts first and they can prioritize. And exist means if a patient is having any problem. Others means if it is irrelevant, like patient is not talking about any health issues. Similarly for medications, like if a patient has gone through certain medication, if it was whether it was effective or whether it was ineffective or it had certain severe adverse effect. So this kind of classification will help for pharmacovigilance. And others represent like non-related. So these are the for machine learning algorithms, we need to have features to train a model. So these are the basic features that we analyzed. So these are, first is contextual or natural language understanding views, like emotions, like coarse grained emotions, like we are trying to analyze the based on a user post, whether the what kind of emotions that user is expressing: anger, disgust, joy, fear, or sadness. Several other fine-grained emotions categories, like user state of feeling, like variance, arousal, and dominance. We try to analyze the sentiments, like what level sentiments, and target specific sentiment, like certain static verb people use, like suffering or feel. So these kind of static verb we targeted to the what kind of sentiment they're expressing. Then we have other figurative language like sarcasm. So for example, it goes from pain to slight discomfort. I can't move. Great way to start a day. So this sentence is usually in this sentence, the patient is sarcastically expressing that it's not going good at all. And personality, like what kind of personality that user is expressing, what kind of his openness or his gesture or friendliness and assertiveness. So these are the personality traits, these are the features that we used for our model. And task agnostic view, like we given a blog post, we get the document representations like in a vector form and we use in the model. So these are the primary 2 blog posts that we used, like daily strength and patience. And we focused on depression, anxiety, allergy, and these areas. So first, for any NLP task, any machine learning task, you need to have a pre-processing step. Then we have this contextual and task agnostic view, and we train a machine learning model for natural language processing, and we try to identify these medical conditions and medications. So this dataset is publicly available. This dataset is created by several human annotators and later evaluated by health professionals. If you have any question, otherwise I'll move to the next one. So this is the last part, that this is my current research in my PhD, named entity recognition. So what is named entity? So named entity in a text is a chunk or a unigram, means a unit to single token, or a multi-token text segment that represents certain concepts of a predefined class. So for example, in this here, French astronaut Thomas Pesquet will return to International Space Station in spring 2021 on board a spacecraft built by Elon Musk SpaceX, the European Space Agency, said Tuesday. So here, Thomas Pesquet, this is an entity which is of class person. International Space Station, this is a mean of transportation, space shuttle. Spring 2021, this represents time. Spacecraft, another mean of transportation, Elon Musk person, SpaceX organizations, and so on. So these are the text segment that represents concepts or an entity of certain type. These are the general few examples. So this is one of the research papers that recently published. Hydroxychloroquine with or without azithromycin is in mild to moderate COVID-19. So this is the title of the paper. So if we go through this title, we can see this paper is having, this title is having this hydroxychloroquine, this is the drug mentioned, azithromycin, this is another drug, and COVID-19, this is a disease. If we go through the abstract, this is the first sentence I pulled out. Again, here are this drug mentions and disease mentions. So once we have these named entities, you can summarize like what is this paper about or what is this document about. So named entity recognition. So this is the two-step process. So first is identifying the mentions in text and classifying into set of predefined categories of interest. For example, this is the sentence. First, identify the text, which text segment represents an entity. Next is classify into categories like this is a drug, this is a disease. So this is what named entity recognition. Once this is the two-step process. So why are you doing this? So extracting named entries from any scientific literature or electronic health record or news articles or any other documents, it is a primary step towards learning a complex structure of it. So, or what it is about, the document is about, or what it is saying. So it can help in, if we go through scientific literature, we can do the author or organization profiling, author expertise identification, time series analysis, question answering, knowledge representations, and so on. So how am I planning to do it? So I'm planning to develop a distantly or weakly supervised framework, which will be flexible and generalizable. So using the existing knowledges. So I'm not, so supervised machine learning, it requires lots of training data, and getting those training data by human annotators is very difficult. So it is very time consuming and very costly. And all these evolving new domains, it is very difficult to get annotations for each and every task, for each and every category. Instead of that, if we can use the existing knowledges such as ontology or the knowledge graph or the dictionary and use those knowledges to generate automatic training data and learn a model with partial supervision from a human for partial like binary annotations or binary key evaluations to filter the noise. So this is the basic architecture that currently I'm doing. So like given a news articles or scientific literature, documents or health records, so these are the data we can extract entities, like any kinds of documents. Existing knowledge we can use like DBpedia, Wikipedia, this MES, Unified Medical Language System, and CTD. So this MES, UMLS, and CTD, this has chemical medical vocabularies like chemical mentions or disease mentions and other complex terms related to medicals. So my focus is why not use this existing knowledge instead of going through the manual annotations. I use this existing knowledge to automatically annotate the data and even learn a model and filter the noise in the model. So like here you can give any dictionary. So given a dictionary and a set of document. So first step I'll do like document pre-processing that is required and automatically annotate the document using the existing knowledge like these dictionaries. So this will be high precision but very low recall because these dictionaries are incomplete. So this will generate noisy annotations like not everything will be perfect. So for example, if in a text in a news article there is a mention of New York Times, this is an organization. Now if in your dictionary if you have New York, so this kind of auto annotation process will match the New York in the New York Times as a location, but which is wrong. So this kind of noisy and partial annotations it will generate and use this domain knowledge and learn a machine learning model and extract the named entities, and from this model and based on the confidence score filter the noisy annotations and iteratively learn or iteratively filter the noises and learn a better model. Also use an active learning and having a human in the loop that will give binary evaluation, so user or human doesn't have to go through each and every sentence and entities. Instead of that, the model can represent the confusion ones, like the confusing ones, like which are the model is not sure whether this will be a particular type of entity or not based on the confidence score. And the human moderator can give binary decision whether the model is right or not. So this will take very less time, and with the supervision, the model can learn better. So if you have any questions. So here I conclude my presentations. Yeah, these are the few references that you can follow. If you are interested in any of this research, you can please feel free to reach out to me, and I can share those data sets or any other details if you need. Now I'm open to questions.
Participants, any question, please? You can unmute yourself.
Yes, ma'am, I've unmuted myself.
Yes.
I'm Srilata, working in Srinidhi Engineering College. And actually, I have multiple questions. I don't know whether I can ask so many questions because I'm already working on this.
Okay.
My question would be like, what would be the best survey paper for depression or actually, I'm working on NSSH for handicapped patients. Non-suicidal self-harm for handicapped people.
Okay.
So what would be the best survey paper for this, sir?
So I would suggest I know the few of the prominent researchers in that field. So probably you can go to their profile. So I currently don't recall. One researcher name is Resnick. So you'll find, if you find any depressing, depression related or mental health related paper. So one researcher name is Resnick. So I don't remember the exact full name. So probably I can forward their research papers or the contact list or their pages where you can find all the related paper to you.
So can you give me your email ID?
Yeah, sure. So
like
it
in
is.
the chat?
Yeah, sure.
And can I go ahead and ask another question?
Yeah, sure.
Huh? Yeah, like how do you analyze the questionnaires that you have given just now in this problem?
In the depression?
Yeah, related to depression, actually, because I'm working for handicapped people who cannot express themselves properly.
Okay.
If that is the case, then how do you analyze such questionnaires?
So if you search for patient health questionnaire, you'll find what is the question, the details of that question, like for each of these classes, what is the definition of that question. So in the reference I have mentioned here, so for example, let me open it. So this is basically used in clinical settings, not on social media. So do you see my screen?
Yes, sir. I can see your screen.
So here, little interest or pleasure in doing things. So these are the questions usually asked to the patients. And here they select how frequently it is they are experiencing those several days, more than half days, or nearly every day.
So
This
what
is
if
like,
they cannot express themselves? Then how would you activate such questionnaires?
like their disability, you are saying?
Yeah, because of the disability, they are so depressed that they cannot express themselves.
So that
Sometimes
would
they
be
just remain
challenging.
calm. They don't say anything.
So I know the few of the research that's going on this kind of mental health studies. So they, instead of this, for those who can't express this, usually they record a video, like the mental health expert will ask some questions and they will go through those, or they will ask them to go through certain activities and they record their video, and based on their facial expressions and their performance, they try to evaluate.
Okay, sir.
This could be last question because I think many more participants are waiting. Thank you, Srilata. I hope you can reach Mr. Joy offline, and you can I think you can always reach him in a mail, and he will be happy to reply.
So here is my email ID. Yeah.
Yes, yes. So now I think we can take the question from Jitendra Reddy. He's been waiting since long time. Yeah.
Yeah, good evening, Joy.
Hello.
Yeah, I'm Jitendra Reddy. My question is, what is the best algorithm to find out these frequent patterns?
Like for depression related that I have shown here. Are you asking about these frequent patterns?
Yeah.
Yeah, so basically I used topic modeling algorithms like LDA. So there are several variations of LDA. So you can probably go through those, like latent
Okay.
question. Yeah.
Yeah, okay, thank you.
Hello, sir. Hello.
So may I ask?
Thank you, sir.
Hello, sir. Hello. Hello, can I speak, sir? No.
Yeah, sure.
Sir, it's me, Amarnath. I am working as an assistant professor in Jain University, Bangalore. I'm an research scholar in Vishweshwar Technological University. A very nice presentation.
Thank you so much.
The thing is, like, how this deep learning helps in analyzing medical field, or else in image processing or medical imaging, whatever the field in future. What is the role of machine learning as well as deep learning, according to you?
So I feel this medical field, machine learning, like for image analysis or text analysis. So here, like in my task, I have used for as a classifier in first of the two tasks, and later I used for other information extraction things. So I think medical thing, I would say the most attractive area will be the deep learning or machine learning algorithm is used currently is for electronic medical records, like where you have lots of like a patient's medical history over the years. So a doctor or a health professional cannot go through each and every details, like all for hundreds of pages, like what are the patient's problems in several years, or what are the medications they have gone through. So if you don't have any knowledge representations from those medical records, for example, or the doctor can't visualize what are the problems the patient has, or the several medications the patient has gone through in several years, he might tend to prescribe similar kind of medications that patient has been through maybe in a few years before, and it had some side effects or adverse effect, but doctor doesn't know, like what is this patient about, or what are the medication it has gone through, the patient has gone through. So if, for example, if you have this kind of machine learning algorithms that can extract these named entities and like what are the diseases the patient has, or what are the drugs, what is the time duration the patient has gone through certain medications, and you can represent in a visualize, you can represent or visualize in a time series analysis you can present in a time series analysis. Now the doctor he doesn't have to go through all the details of his medical records, past medical records. He can just see based on time series analysis what are the drugs and what are the side effects the patient has experienced for certain drug, and in a way he can recommend effective, and he can go through effective process to treatment. So this is one of the areas I find machine learning is really helping.
One of the areas. Okay.
Thank you, Joy. Can you quickly go to the chat window? I think, hi, Joy, Sandeep here this side. Can you quickly go to the chat window, and maybe you can answer few questions, I think, because there are participants who have been posting the questions in the chat window. Can you go to the chat window?
Yeah, I'm here.
Yeah, I think you can just select few questions. You need not to answer everything because there are many questions pouring in. Or you want me to read?
Major role in the process of data patterns. So question is about, this is from Jagdish Kumar. So another question is, how is deep learning helping in medical field? That we have already talked.
Yes, we have already answered that. Yeah.
Share the links.
Somebody is asking on the books, I guess. I think Srilata, yeah. Srilata, she's asking on any book you can recommend for psychologist and some diagnosed and approach for such patient.
Yes. So Srilata, if you could give me, right now I don't have any, I don't remember, I don't recall the book names or papers I've gone through. So if you could email me in this sane.9@right.edu, I can forward you those informations, and which book we can find for feature views. So feature views, not in any books you'll find, I would say. Probably you can go through this NLP, you need to go through NLP paper. So the feature view that I have used in my research. So based on several works in that area or in other area also, like using in a transfer learning. So just analyzing the data and what kind of feature views that will help in your case. So that, I guess, yeah.
Thank you very much. I hope, I hope we have taken enough questions, and I think one more question is there. I think this can be the last question. Best tool to predict the patterns, I think, from Prasad, Madhula Prasad.
Yeah.
Yeah.
So I would suggest like extracting those. Easy way would be like extracting unigrams, bigrams, and trigrams, and based on frequency you can sort, or you can use the LDA algorithms. Like there are sentence LDA or LDA to break, and several others that use the sentence representations and the context of several context of documents, and vectorizations of each and every word, and based on the similarity they try to extract the frequent patterns. So LDA variations, I would suggest LDA or LDA to break or sentence LDA.
Yes, thank you, Joy. I think we have taken enough question now, and I would like to thank you for accepting our request and be one of the speaker for this international conclave. And I believe that many of the participants are research scholars, so they would be very happy to take the input from you. And I believe they will interact with you in future, because I think Srilata and many other scholars and faculty members, they were trying to get more information. So thank you once again. Thank you very much for taking out the time. I know that this is a very critical time, and this pandemic situation, everyone is so busy. Yes. Thank you very much, Joy. And I hope that in future we would like to collaborate again for such kind of events. Yeah. So thank you very much.
Thank
you. Do we have any appreciation certificate here?
Yes, sir.
Yeah. Yeah, so this certificate, I think our co-convener, my co-convener, Dr. Tilotoma Madam is going to send you. I think that is what is planned. Yeah.
Yeah, sure.
And anything from Oblesh sir? Any final remark?
Yes, sir. Nothing, sir. Thank you, sir. Yeah. Thank you very much for a nice session. We've gone through more insights on NLP and particularly named entity recognition. Thank you, sir. Thank you very much.
Thank you.
Very good session.
Thank you so much for the opportunity and for Anurag University for organizing the event and Dr. Tilotoma Goswami for reaching me out for this opportunity. Thank you.
Thank you, sir. Thank you very much.
Thank you, Joy. Yeah, thank you very much.
Have a good night.
Good day. Good day. Yeah. Good day and good night to everyone. Yeah. See you tomorrow, everyone. Yeah, for another session.
Thank you, sir. Good night to all the participants.